design connects with people, and it connects with helping people understand the world that they live in a tangible, tactile way. When you have this thing happening in a laboratory that feels so far removed from a citizenship, design has a role to play to be able to extrapolate some of those ideas and play with them, and to see what scope they have for existence outside of the lab. What else could it be? So the bigger picture is that when we talk about divesting from fossil fuels to power a green economy with wind and solar energy, what we often forget is that our material world is predicated on petroleum too. And so when we look at fibers like polyester, when we look at the chemistry of finishing textiles, of dyeing textiles, they're all derived from fossil fuels. So Project Coelicolor is a project that seeks to integrate design thinking with biological fabrication. How do we take biological processes and integrate them with design processes? In 2011, I started a project that explored how we could integrate design with biology. I met a scientist at University College London called Professor John Ward, and he introduced me to a microbe called Streptomyces coelicolor. So Streptomyces coelicolor is an organism that we've all interfaced with in some way. The smell of rain after a dry period is caused by Streptomyces coelicolor releasing geosmin, which is a compound that we associate with the smell of rain, into the atmosphere. It produces a pigment molecule called actinohodin. It's blue, but depending on how you work with it in the lab, it can indicate purple, pink, red. So when we're working with pigment-producing bacteria, what we are seeing is that we're reducing water use by up to 500 times than ordinarily found in industry. We are not using any chemicals to fix those pigment molecules onto the textiles. This is fascinating because any textile designer will tell you that a lot of the harm is being caused at this finishing and dyeing stage because of the chemistry inputs that go into being able to create that bond between molecule and fiber. So we want to understand at what scale this can start to replace these very damaging practices that are ruining our waterways, that are causing people to get sick because of the chemical exposure that they have, and that offer an alternative to petroleum-based industries. Fundamentally, for us to respond to climate change, we have to reduce our carbon emissions, and that does mean keeping oil in the ground. But you and I still need to wear clothes. We still need shelter. We still need, infrastructure. And so, the question of our time is, what are the material processes and practical applications we can bring about to create that change?